Hi, today we will learn electromagnetic radiation. As we see electromagnetic radiations, we feel electromagnetic radiations all around us. There is solar radiation, heat radiation, and there are so many other radiations coming from cosmos. Now one can think that these radiations are wave as suggested by hygiene. So there should be some particles, some medium, and in terms of vibration of that medium, these electromagnetic radiations can be explained. But it was found that electromagnetic radiations are present in vast expanse of your space also, and where there is not any material medium, in vacuum also you can find electromagnetic radiation, but there is changing electric field and changing magnetic field. Now these electromagnetic radiations are self-sustaining. They are autonomous bodies. They do not gain energy from any other body. They have their free existence. So for understanding electromagnetic radiation, we need to know the law of electricity and the laws of magnetism. So what are the laws of electricity? Gauss's law of electricity. So you know that flux, electric flux is equal to surface integral of electric field, and it is equal to charge enclosed, stationary charge enclosed upon epsilon naught. So it suggests that stationary charge produces electric field. Now Gauss's law of magnetism. So Gauss's law of magnetism suggests that magnetic flux passing through any enclosed surface is equal to surface integral of BdS, and it should be equal to 0. Now Ampere's circuital law. All these we have learned. So we are just recalling all these laws of electricity and law of magnetism. So Ampere's circuital law suggests that line integral of magnetic field is equal to mu naught I. And you can write mu naught as dq upon dt. So what is this dq upon dt? Now, rate of flow of charge. When charge flows with uniform velocity, then it creates magnetic field. So your stationary charge was creating electric field, and this your moving charge with uniform velocity is creating magnetic field. But these fields are constant. E is constant, B is constant, and these cannot be electromagnetic radiations, as electromagnetic radiations are time varying, electric field and magnetic field. As you can practically measure that, the electric field and magnetic field are not constant over there. So then this Biot-Savart law we have learned from before, this suggests that magnetic field is equal to mu naught upon 4I ideal sine theta upon r square. So it also suggests that changing flowing charges, rate of flow of charge, when charges flow with uniform velocity, then it creates magnetic field. So till now you could know that stationary charge creates electric field, and moving charge, which is moving with uniform velocity, it creates magnetic field. Then came Faraday's law of electromagnetic induction. According to this, EMF induced is equal to minus of rate of change of magnetic flux. But we know from our electrostats chapter that EMF is nothing but potential difference. When resistance is very low, you can also say that potential difference is equal to EMF. And we also know that rate of your dV upon dr, potential gradient, is equal to electric field. These all things we are recalling, we should know from before. So your dV upon dl, you can say it potential gradient. And this is equal to electric field. So instead of writing V, you can write EDL. And then from this equation, any equation, I am writing A. So you can find that this rate of change of magnetic flux is equal to EDL. So it suggests that a changing magnetic flux produces electric field. Till now, we learned that a stationary electric field, a constant electric field, cannot produce magnetic field. A constant magnetic field cannot produce electric field. But here in Faraday's law of electromagnetic induction, we could know that a changing magnetic field, changing flux, magnetic flux creates electric field. And these electromagnetic radiations are self-sustained. They do not derive energy from any other external source. They are autonomous bodies. They have their own energy. They have their own momentum. So if changing magnetic flux is creating electric field, then Maxwell suggests that a changing electric flux too should create a magnetic field, and vice versa. Then only the electromagnetic waves can sustain by their own. When a changing magnetic field creates electric field, and all these we learned in our previous classes, and all these laws are called Maxwell's laws. Maxwell has derived 4 laws, and these are the 3 laws from before. Now Maxwell suggested that when a changing magnetic field is creating electric field, so should a changing electric field also create a magnetic field. So Maxwell applied Ampere's circuital law, and by the consideration of logical consistency in a conductor which is containing, in a circuit which is containing a capacitor, he showed that by logical consideration, by logical consistency, a time-changing electric field should also create a magnetic field. So here Ampere's circuital law. What is Ampere's circuital law? Here I have taken one capacitor in which I current is given, and this current is varying with time. So as per Ampere's circuital law, due to this current, a magnetic field should be created at any point on any circle perpendicularly placed. I have taken here a circle of radius r. This circle is perpendicularly placed to this current carrying conductor. So applying Ampere's circuital law on this for finding field at point P, here I have applied Ampere's circuital law, which says that line integral of magnetic field must be equal to mu naught I, and dl can be integrated. Here this complete length of the circle can be integrated to 2 pi r. Its complete length is 2 pi r. So B is arrived. There is B positive. It is not 0. B is not equal to 0 at this point. There is some magnetic field outside capacitor. So now if you take the same this closed circular loop, but the shape of the surface is changed, then what happens? Boundary we have keeping the same, we are not changing boundary, and your Ampere's circuital law is about magnetic field on the boundary. It is the boundary condition. It is summation of all magnetic field on the boundary itself. So if one way you are finding B as mu naught upon 2 pi I upon r, then from any way you are trying to find magnetic field here, it should be same. It should not change. Now Maxwell took a different kind of surface. Boundary remained same, and he had to find magnetic field at this point P only, but he took a surface of this boundary different, a pot kind of surface, and a part of which is inside this capacitor. Now inside capacitor you can consider that there is not any current. Current is 0. So Ampere's circuital law is about magnetic field at the boundary due to current at the surface. And at the surface you can see there is no current. Current was outside only. And Ampere's circuital law is about magnetic field at boundary. Boundary is same. Magnetic field should remain same. But due to change in surface, here current through this surface becomes equal to 0. So now when you apply Ampere's circuital law in this condition, then you find magnetic field at the same point, 0. Here you find magnetic field is equal to 0. But this should not happen, that magnetic field at the same point is having some finite value, and by other way, if you are finding magnetic field, here field should be 0. It should not be happen. So both are contradicting each other, and this contradiction has arises due to application of Ampere's circuital law. It suggests that something is missing in Ampere's circuital law, and due to that this contradiction has arisen. So now Ampere went this way. He found electric field inside the capacitor. We know that electric field inside the capacitor is charge density upon epsilon naught. In electrostats, if you could recall, electric field is equal to charge density per unit epsilon naught, and charge density can be written as charge per unit area. So now flux phi, electric flux, it is surface integral of electric field. So when you place electric field here, value of electric field, that is your Q upon A epsilon naught, and cancelling area, you will find that electric flux is equal to charge enclosed by epsilon naught. Electric flux is equal to, and this is Gauss's theorem also, that electric flux is equal to charge enclosed upon epsilon naught. Now when you differentiate this flux with respect to time, you will find that d phi e, rate of change of electric flux with respect to time, is equal to dq upon dt upon epsilon naught. And you know that dq upon dt is a current. And this current which is flowing inside the plates of capacitor, he took as displacement current, I displacement. Here a current is obtained inside the capacitor, and it is different from conduction current. A current that flows through conducting wire is called conduction current, and a current which is your in the space of any capacitor, a current has generated here, developed here. This current is called displacement current. So we have two kind of currents: current conduction and current displacement. So the net current should be equal to the sum of the two currents, conduction current and displacement current. So the form of the Ampere circuital law will be same, leaving the form same, only changing this missing part of current. Now Ampere circuital law has been changed to this value, mu naught IC plus mu naught, and ID has value epsilon naught into d phi e upon dt. This is the value of ID you can find from here. So now you can see that there is a changing electric flux which is creating magnetic field. So when no alternating current, you have uniform current, DC current, then this electric field will not be changing with time, then this part will be removed, and your magnetic field is due to conduction current. But in space you will find that there is absence of conduction current. There is no conduction current. There is only changing electric field. So this changing electric field is creating a magnetic field. So you can consider that magnetic field can be created by two ways. One is by electric current and another is by changing electric field. Let me write magnetic field can be created by number one, current electricity, and number two, changing electric field. So this is how the existence of electromagnetic radiation can be considered. That it is not taking energy from any other source. It is self-sustained system and which is moving, traveling in the space. And it contains time-changing electric field, and it contains time-changing magnetic field. So now it is proved that from Faraday's law it was proved that time-changing magnetic field creates electric field, and now from your Maxwell's Ampere law, this is your Maxwell's Ampere law, it is proved that a time-changing electric field also creates a magnetic field. So this is how you can define electromagnetic radiation. And one thing more here in diagram I should say you. The current was along this direction. So your electric field was also along this direction, and you could find that magnetic field is along tangent direction of this circle, which plane is perpendicular to current carrying conductor. So from here you can find that electric field and magnetic field both are perpendicular to each other. So now you can define electromagnetic radiation. Okay. At some point you have only electric current which produces magnetic field. At some point you may have both current and time changing electric field which is producing magnetic field. But in space when you will go, then you will find that there is no conduction current. There is only time changing electric field which is creating magnetic field. So now your electromagnetic radiation can be defined. I am writing here. The two fields are perpendicular, so EM radiation is time varying electric field which creates time varying magnetic field perpendicular to it. And vice versa, the phenomenon goes on repeating itself. And the velocity of this EM radiation is perpendicular to the both the fields. So this is how you can define EM radiation. Now your justification of prediction of displacement current. You can justify the prediction of displacement current can be proved also, because when you will find magnetic field outside this capacitor by a very sensitive device, here you have magnetic field due to Earth's magnetism and due to this current flowing through the wire. So the net magnetic field can be obtained using a very sensitive device. Now if there was no displacement current inside, then there would be only your magnetic field due to Earth. But when you measure magnetic field inside also, you will find that the field comes equal. The field outside is equal to field inside. So this justifies the presence of displacement current. Now as we know that electric field and magnetic field are perpendicular to each other, so electric field will be parallel to displacement current, and magnetic field will be using your right hand thumb rule, you can find that it is along tangent direction coming out in this direction. Now if you take a cross section area parallel to the plates of the capacitor, then you will have this figure diagram and you will find that electric field is going inside. Magnetic field is along tangent of the circular loop. So this is how you can justify and you can define electromagnetic waves. Okay, I conclude.